7.3. So what is 7.3? 7.3 is box plots again, but this time you're sketching what we call parallel box plots. Parallel box plots just means you have multiple box plots on the one timeline. Your skill for 11s later on would be to sketch them. 12s, your ability is to sketch and interpret. Okay? So when you're interpreting, there are 4 key parts that you need to interpret. Let's go through them. Number 1, when you're interpreting and you're comparing the box plots, you need to compare what they call central tendency. What that means is median. What's another measure of the center again? Give me another one, Jasper. There are 3 of them. So we got median, mean, very good, that's 1. And the last one? Mode, very good. That measures the center. Okay, so center of your data, where is that? You use these 3 to help you figure out roughly what the center is. Number 2, S, spread, very good. This is talking about how wide is the data. Variance. What about 3? So you talk about the measure of the center. You then talk about the measure of how wide the data is. Then what's number 3? Let's go with Pav. What do you think number 3 is? So you got measure of the center, measure of the spread. What else can we look at in terms of data? Starting with O. Outliers. So you got to look for data that is outside of the boundary. And lastly, this one should be easy. Shape of what can I please have? Distribution. Very good. So let's do a bit of an example practice. Here is a picture of 4 classes, 10A, 10B, 10C, 10D, right? You can see that they all look slightly different. They have different minimum, maximum, inner quartile range, and median. These are the percentage marks the classes get. So we're doing a comparison of 4. Here's an example of how you're meant to describe. You don't have to be in this detail, but look at the way I'm sort of giving you a template. Whatever you take out of it, what you can remember, that's what you do for the end of year exam. Yeah, so here we go. Here's the example I wrote. I said, in this maths test, the box plots show clear differences in performance between the 4 classes. So you don't have to say that. But let's look at which one, without actually looking at my blurbs, which one has an overall best performance, general? You're saying 10B. Jasper says 10B. Can I get a reasoning? So when you say 10B has the best or overall performance or general performance, you have to give a reasoning. So let's go with... Oh, he was away. You were here though, Connor. So, Connor, what is one of the key things that you can look for to know general performance for 10B? So Jasper's saying 10B is likely to have the best general performance. What will we look at? Pav and Finita? You guys focus, please. Ooh, I see what you're saying. Skewed means, so you can look at skewed. If it looks like that, it's true. No, it's possible. In this case, there is a skew actually, but a skew median, not a skewed data. So the distribution looks pretty even so far. The only difference is that the median, the middle, is slightly different. Okay, but overall, the whiskers are roughly the same. So that's how you can kind of tell that it's roughly a nice distribution. The only thing is there's a skewed median. So even though it's slightly like that, there might be more data sitting in that region. That's what it means. Yeah? What else? What can we look at? Let's go with Callum. If you're looking at 10B, because 10B is the correct one with the best general performance, but what things do you have to look for? Good. So mean is one of them. You can look for the mean, but it's hard to look at it for the mean in a box plot. So what's another measure of center besides the mean? What can you look at? Let's go with Billy. So looking at this problem here, Jasper's saying that 10B has the better performance in general, right? And I'm saying, well, if you had to dissect it, what other measure of center can you use? So we said, Callum said mean, but you can't see the mean in a box plot. So what other thing can we look at to then say that maybe 10B has a better general performance? IQR is one of them, but that's not the center. But yes, IQR is one of them. So I'll just highlight the IQR for you guys to look at. We had mean. What's another measure of center again? Mean, median, and mode. Box plots, you can't see the mode easily because it doesn't tell you the data, so you don't know what the mode is. You can't even tell what the mean is. The only thing you can tell is median. So you compare the median. Here's the median. That's Q2. This is Q2. This is Q2. This is Q2. Now, if you look at all the Q2s, 10B does have the highest Q2, sitting at roughly maybe 78%. Okay? So in the description, can you see how I wrote here? I wrote 10B has the highest median maths mark of 78%, indicating strongest general. I'm not saying they're the best, because you still haven't looked at the other data parts. I'm saying in general, if the 50th person, where if we had to rank them, they have a general better median. Just like schools, when you do VCE at the end of year, they say Baldwin has a median of 34, Melbourne High has a median of 37, Viewbank last year was 31. So that's a measure of the 50th person, but it doesn't talk about you, the cohort. So that's why you then look at the spread. Now, Billy said IQR. IQR is the width of each box, right? Now, the wider the box, so the widest box clearly is roughly 10D. 10D has the widest box. What does the widest box mean? If you have a wide box, what does that mean? Pav, what do you think if I looked at their data, if you had a really wide IQR? Yeah, and so if the results are not compact, what does that mean? What does that mean? If your data of the results, imagine this class, the 25th person and then the 75th person is really far apart. What does that imply about that class? Very good. There's a huge variance. So ideally, what's a really strong class? It's when you have a smaller box. If you had a box that was like this, see, a very small IQR, and then a median, even if the median was exactly the same as 10B, a smaller box implies more consistency because everyone's roughly the same. The 25th person is still getting 70-something%. The 75th person is still getting 90-something%. That's impressive. Okay, so the smaller the spread, the smaller the variance, the better. So two things you're meant to look at. Central tendency, mainly look at the median. Spread, look at the IQR. The range also tells you as well because the range implies if there's any outliers. So 2 and 3 tie together. And your last one is the shape of distribution. Is there any skews? That's where you were sort of going at, Connor. So skews, which one is likely to have a skew? So look at the graphs. Which one most likely has a skew out of all of them? Which one looks like it has a skew? 10A. Yeah, 10A. Good. So this one, some students will call it negatively skewed because they can see it looks like it's on the left. This is being skewed towards the right. Okay, so that means there's some, like most people sitting on the bottom, and it's right skewed. Okay, so when you talk about the distribution, those are things you should be looking out for. Here we go. Let's look at my description. I said that 10B has the highest median, fair call, 78%, strongest general performance, whilst 10A has the lowest median of roughly 61%. So if you look at the data, yeah, it's the lowest median. So we're just talking about strongest versus weakest. Then we say, so here I wrote weakest. Then we look at 10D. You told me that has the largest interquartile range. So we can see this is what Billy was suggesting. Look at the width of the box. 10D has the widest box. And what does that mean? So you always have to then explain what that means. So that implies showing the greatest variance. Write that in. And in simple words is what Jasper was saying. It just means that the smallest person to the highest person, there's a huge gap between them. Okay, so variance implies width. Okay, well, ideally we want the smallest and the highest person to be close to each other. That means it's a really strong class. Consistency. So which class has the smallest IQR? To me, it kind of looks like 10C. 10C has the smallest IQR, and that implies that class is the most consistent. So if whoever's teaching that class, they're doing pretty well because that means the lowest student isn't too far away from the highest student. That's what a good class would be. So ideally, if I were to teach a class, I would want my classes to have a smaller width because that means I have an impact. Because most likely, in general, most classes overall has a big skew. Okay, there's always going to be a huge on tail end and a huge on the upper end. There's always a disparity. Someone's going to get 25% and someone's going to get close to 100% for the test. But if I can get the lowest end getting up to like 40, and I can get my highest and still in that 90, that's great. That's a smaller width. I have a stronger class. Even better if my weakest student was getting 80% and my best student gets 100. That implies that my class is really strong. And that's because of my input. Otherwise, it's just general luck based on their intelligence. Okay, so the width tells you consistency and the median tells general performance. Okay, range tells you, do you have any extremes? Smallest person to the largest person, whoever scored the best, who scored the worst. Do I have an outlier? Okay, so that's the explanation. Here we go, let's try our next one. 10C has the smallest IQR, which indicates the most consistent, so fill this in. Consistent performance, no outliers observed in any class. In terms of shape, 10D is probably the most symmetrical. How do I know? Look at the whiskers. Look at the whiskers, they're roughly the same. And look at where the median is. Does it split the box roughly in half? 10D is the most symmetrical. Okay, 10D has the most symmetrical one there because the median is centrally located within the box and the whiskers are the same, roughly the same length. Whereas 10B shows a slight, and this is what Connor was saying before, 10B, when I asked him, he talked about the distribution. He said it's slightly skewed. And that's true. Shows a slight positive skew. And you look at that. See, most of the data is roughly sitting here. In the tail is even, but in the box you can kind of see there's more data sitting just around this section before it tails off. So it's a very slight positive skew. It's not an obvious one, but the median shows that there might be a few people scoring further this bottom end, that's why the median is lower, but likely that it will affect the mean as well. Okay. All right, let's see. What else do we also have? So we've got that 10A and 10D are slightly positively skewed. 10C is slightly negatively skewed. Negatively skewed, for those who don't know, let's look at 10C. Negatively skewed is when the tail end goes towards the left. That's negatively skewed. Okay. All right. So I know this was a really comprehensive paragraph. That is not expected at the end of year. Okay, but can you see how I'm picking out information? What they want end of year is that bits and pieces, you understand the three key things. One, who does best and who's most consistent and any extremes. Those are the three key points that you want to look for. I would say, or we'll say, no, they don't want to have the, they want to have, I wrote it so that you can memorize or feel like it makes sense of what you're doing. In the exam, they'll say something like describe the distribution. Now that will be a very straightforward question. Usually in the exams, they give a scenario. They have class A, class B, class C. Then they'll say something like describe the differences between each class. Or like, what is the difference between each class using statistical justification? Something like that. So then you have to then go through center, spread, and then any outliers to back up your reasoning. Usually 3 points is all you need to say. So 3 sentences. So one about general performance, one for consistency, and that's looking at IQR, and then last one is any extremes. Or even distribution. That's your general sort of go-to. Cool? So when you're doing this exercise for 7.3 for year 12s, what you're practicing, what I want you to practice is writing sentences in those 3, because that's the difference between 11 and 12. So 12's interpreting, 11's is calculating. Cool? So here we go. Let's flip over the page. This is your data. So I got 2 classes. Okay, so there's box plots for number of hats being produced in a factory. This is 2012 production, and that's 2022 production, so after a 10-year gap. what we want to see is that over 2 days, okay, over a 2-day period in 2012 and 2022, we want to do a comparison. Here's the year 11 skill. Year 11 skill is to look at a box plot and then fill in the spaces. Okay, so look at 2012. I'm going to ask the year 12s and year 11s. Oh, actually, year 11s, you're doing your own thing. So year 12s, here we go. Let's go with Billy looking at question A. 2012, based on the box plot, what is my minimum? 10, very good. So you can see it's roughly 10 for 2012. So little dot at the end. Let's go with now Finita. Finita, your shot. So on this sheet here, you got 2 box plots. I want you to look at 2012. Look at 2012 and then tell me which one's Q1. So this is a year 11 skill, identifying key features. So Billy told me minimum is at 10. So that's true. I want to know what Q1 is. Q1 is 12. Very good. Is this line here? That's Q1. And it's at 12. Very good. What about Q2? Let's go with Josh. For 2012. Yep, it's the middle one. Very good. So that's roughly 15. Okay, so you can see the middle's roughly... Oh, did you? Sorry. Do you know what Q2 represents? Good. Median, which is the middle. Very good. Q3, Connor. We've got now 20. Very good. And then the maximum, Callum? 30. Very good. Now, the maximum would have been 36. Okay, but that's an outlier. Okay, so an outlier. So the maximum within the data that can be achieved is technically 30. Okay, or sometimes before you calculate the outlier, the maximum is actually technically 36. Okay, because that is your largest number that you got. It just so happens that the maximum is your outlier. Okay, but in this specific scenario, if we're just looking at a 5-number summary, technically the maximum there is 5, but we know the reality is the maximum is at 36. It's just that that's an outlier. Okay, so maximum is an outlier. All right, next one. 2022, so now we can read it. We can say 2022, minimum is 12. Q1 is 22. Median is roughly 27. 30 for Q3. And then maximum is 34. I'm going to write here 36 to remind you. That's the real maximum, and it is also the outlier as well. Okay? Because if you change that maximum, then you change the whole median and all the data. So it's just that in the picture, that's your new maximum, but the real maximum is 36, but it's also an outlier. Okay? All right, so number B. Determine above what value were the top 25% of hats produced in 2022. So here's 2022 data. How many hats were sold in the top 25%? So 25%, top 25% of hats produced in 2022. What number? How many hats were produced? Let's go with Pav. So Pav, looking at this question, 2022 bucks. And it's asking, determine above what value. So how many hats had to be produced to be in the top 25% in 2022? So this factory had to produce hats. And I want it to be in the top 25%. Good. So we say 30 and above. So the value is 30. So when they say above what value, it has to be above 30. So say above 30 hats produced. Okay, so you need to have 30 or more hats to be considered top 25% in 2022. That's the interpretation of graphs. So that's a year 12 and bit of year 11 skill. Determine, number 2, determine between which values were the middle 50% of hats produced in 2012. Let's go with Billy. So looking at the 2012 data, between how many hats to be 50%? So I want which values for the middle 50% of hats produced? All right, so let's have a look. So it has to be between the IQR, that's your middle 50%. This is your upper 50%. This is your lower 50%. So middle 50% has to be between 12 and 20. That is correct. That's your IQR. So between 12 and 20. That's the middle 50%, which is the general data. Okay, so if you're selling between 12 and 20 hats or produced 12 and 20 hats, that's considered 50%. That's the normal range for this factory in 2012. If you look at the normal range for 2022, you can see it's improved. So after 10 years, their normal range now is between 22 to 30 hats produced. That's what you do as a comparison. So you can use your own way of explaining when they ask you, compare the hourly hat production for the 2 different years. That's a typical year 12 exam question. So then you have to use your skills to then analyze them. Okay, so I've done a little gap section for you to fill in, but that's the idea. So imagine in your exercises and your exams, it will not have this template. You literally will not have these paragraphs. Okay, you have to come up with about 3 sentences to identify key features for comparison. So what I did was I wrote the distribution of hat production in 2012 was, and if we look at the shape, it's skewed. Is it negatively or positively skewed for 2012? Negatively or positively skewed? For 2012. Yeah, 2022, you're right. It's negatively because that N is being pulled in the negative direction. This one is getting pulled in the positive direction. So it is positively skewed. And there's an outlier 36 hats per hour. So 36 hats per hour, that was a once off, not a general thing. The distribution of hat production in 2022 was, in this case, it was negatively skewed. With outliers at, very good. So we got outliers at 9 and we got outliers at 4. So we go 4 and 9. The parallel box plots show that median hourly hat production in 2012, 15 hats per hour in 2012 versus a lower than in 2022. How many hats production in 2022 there was a median? Where's the 50th percentile? So in general, what's the middle production in 2022? How many hats do they normally sell? Very good. So again, you filled in the data up here before. So you got 15 hats for 2012 and 2022 is 27 hats. So you'd say they've moved their productions per hour from 15 hats every hour to 27 hats every hour. That's an improvement. And then here's your 3 points. One's median comparison. Here's a shape comparison. And your last one is your spread. So any variance. The IQR for both 2012 and 2022 was and we can see the IQR, 12 to 20 is 8. And this is also 8. So it is still the same. Okay, so what they've done is they've just more efficient. So the consistency is still the same from 2012 to 2022. The only difference is they can produce more now. And there's lots of reasonings there. So if the exam asks justify a reasoning or possible reason, you could say maybe their machines are better, they have more efficient processes. We don't know. But for whatever reason in 2022, after 10 years, they are now producing much better. As in more numbers than they did before. That's the skill that you're practicing for 7.3. So that's for 12s. Year 11s, you don't have to. But if you understood what I was describing, then when you're doing the SAC, there is parts where you interpret the data. 12s, you have to know how to interpret. Cool? All right, that's it for today. So that's 7.3 when you're working through the exercises. Year 11s don't have a 7.3, but 12s, you got a 7.3 to do. Make sure to do 7.2, which is constructing box plots if you haven't.